Okay, today in IM2 we're going to cover 8.2, which is Similarity and Transformations. The first question is, when a figure is translated, reflected, rotated, or dilated in a plane, is the image always similar to the original figure? The answer is yes. The corresponding sides are always congruent or proportional, and the corresponding angles are always congruent. So, two figures are similar figures when they have the same shape but not the same side. So here we go here. This is your definition from the book. For two polygons to be similar, corresponding angles must be congruent and corresponding sides must have lengths that form equivalent ratios. The first thing that you need to do when you're looking at these is to be very careful, because you don't want to go, okay, A and F, because you can see right away that those have a different measure. So you want to make sure that you stop and look at your diagram first and notice which angles are the corresponding angles. So I can see now that angle A is congruent to angle E, angle C and angle G are congruent, and that leaves angle B and angle F. Now look at your similarity statement and you will see that those angles line up. A is congruent to E, B is congruent to F, C is congruent to G. That's why it's so important that you get your triangle named with the corresponding parts in the same order. So over here, we've got all of the angles listed. And then I want you to notice that if you go by the measurements, okay, so we have AB is the side between 43 and 47. So that would be corresponding to this. So you could say 60 is to 30. And then you would go to the second side. BC is the one between 47 and the right angle. So you would go 48 is to 24. And then the last one is 36 to 18. And as you can see, those are all equal. And they correspond to the proportion that was set up down there. Now, they don't always tell you which one to do first, but I would go left to right. So that means in this case, it would be the larger figure to the smaller figure. In other times, it will tell you which one to put first, but you always have to pay attention and make sure you do the corresponding parts. Okay, so this is just some basic reminders. Hopefully this is all review. Similar figures have the same shape, but not necessarily the same size. Corresponding sides, which you can see by the blue arrows, of the two figures are in the same relative position. This one has been rotated. Okay, this one has been translated up and over, down and over. And two figures are similar if the lengths of the corresponding sides are proportional, which we just discussed, and the corresponding angles are all even. So this one would be, this angle here would correspond to this angle here. Okay? Okay, in this example, we're just going to do some quick evaluating. So we want to find which rectangles are similar. Since they told us that they are rectangles, we know right away that all the angles are right angles. So that means that the corresponding angles are congruent. Now we just have to find which sides are proportional. So what I'm going to do is I'm going to compare the first set. So I'm going to go 10 to 12. Then I'm going to do 4 to 5. And I can see that those are not equal, so these are not similar. Okay, so then I'm going to do 10 to 5. I'm going to do this one to this one. And then I do 4 to 2. And I can see that those are the same, so therefore J is similar to L. Okay, let's try another one. Again, they're all rectangles, so we know they're right angles, and so the corresponding angles are congruent. So now I'm going to compare 8 to 6, and then I'm going to compare 4 to 3, and those are equal proportions. And then let's just check the last one to see if that works, and it's 5 to 2, and that is definitely not equal, so it's A is similar to B. Okay, this is a great example on page 470 of your book, and you can review it in there. what they're going to do with it is they are going to actually do the transformations step by step on the graph. But I want to show you that life can be a lot easier than that. So remember that they're always going to give them in the order that is recommended. So the first step is we're going to take A and we're going to write down each of our points. So we got A, we've got B, this is our original point, and we've got C. Okay, so this is my original x, y. And my first step is right here. It tells me to add 5 to each x and add 1 to each y. So I go -4, plus 5 is 1, and 1 plus 1 is 2. Then I go -2 plus 5 is 3, and 2 plus 1 is 3. And then last, -2 plus 5 is 3, and 1 plus 1 is 2. Now we're going to do the second step, which this now becomes our original xy, and the change they want us to make is 2x, 2y. So we're going to go from here and do 2 times each of these points. So 2 times 1 is 2, 2 times 2 is 4, 3 times 2 is 6, 3 times 2 is 6, 3 times 2 is 6, and 2 times 2 is 4. And now we're ready to look at their picture. So you can see that what they did first was they did the translation. So they went over 5, 1, 2, 3, 4, 5, and up 1. And then they got this point, and they did that with each of them. Then they did the dilation. Okay, and remember that you have your center of dilation is always going to go through the points, the corresponding parts. So like that. So that helps a little bit. But if you look at this carefully, what is my new A? And this we're going to call A double prime. This is A prime, B prime, and C prime. And we'll call this A double prime. And then look at B double prime is 6, 6. We're correct. And then C double prime is 6, 4. And there it is there. So if you know how to use coordinate notation, you can find your new points very easily. Okay, so I want you guys to each take one of these. You can take, it says or, so you're going to push pause and do just one of them. So after we're done, I'm going to come back and do A for each of you, or the first letter of each of them. But before I let you go, before you push pause, I want you to know that the change in coordinate notation for a reflection in the y-axis, that means it's going over the y-axis, okay? That would be to go -x, y. So anyway, the x is now opposite. So if you had 2, 3, that would become -2, 3. If you had -4, 5, that would become +4, 5. So the only thing you're changing is the negative on the, or the opposite sign on the x. Okay, and then this one, the rotation around the origin, you're going to say that that one is xy, and here's how it affects it. And it's kind of confusing, but pay attention. So -yx. So I'll do a couple of examples of that one. If our number was 2, 3, then that would change to -3, 2. Notice that the y bumped up to the front and became negative. The x just slid to the back. Okay? And then if I had -2, -3, the y would flip to the front and be the opposite sign, so it would be positive. The x would stay the same. So there's just a couple of examples. So go ahead and push pause and try one of these, and then we'll come back and go over them. Okay, so I just want to do the one of the steps for each one of these. So A is 3, 6, and that's my xy. And the first thing I'm going to do is go x minus 5, y minus 3. So I get x, or 3 minus 5 is -2, and 6 minus 3 is 3. And then the next step is to multiply both of them by 3. So that just becomes -6, 9. Okay? Over here, we're just going to multiply. We have r. Okay, r is 12, 8. And the first step, this is my xy. My first step is to multiply by 1/4, both x and y. And so that becomes 3x. Whoops, not 3x, just 3, 2. Okay? And then I'm going to do the second step, which is put a negative on the thing. So I'm just going to go -3, 2. So that's r. Okay? Then for this next one, you're going to take x is 9, 6. That's my original xy. First thing they want me to do is go negative yx. So I'm going to go -6, 9. Now remember, when you're doing this, this one comes from this point, okay? We don't go back to the original point. So now we're going to go 2/3 x, 2/3 y. So 2/3 of -6 is -4. And 2/3 of y is 6. So there's the points you should be looking for to verify. And here are your graphs. So let's look at A on this one should now be -6, 9. And there it is. Okay? Then we look at R. R should now be -3, 2. And there it is. Okay? And the last one, X should be -4, 6. And that is right there. And we're good to go. So don't be afraid to do the coordinate notation. It is a lot easier than doing the actual transformations. Okay, so this one we're talking about describing the similarity transformations. They want you to say what happened to this to get P, this first one, which is where it's starting, ending up looking like this. So the first thing I'm going to do is I'm going to write down all my points. So P is -6, 3. Q is 3, 3, -3, 3, sorry. R is 0, -3. And S is -6, -3. So I'm pretty sure that I'm going to reflect this over the y-axis in order to get started. So this is my original x, y. And if I'm going to reflect over the x-axis, remember that that is going to cause the x to be opposite and then y. So here's my change. It's going to be 6, 3. Nothing happens to the y. +3, 3. 0 just stays the same because there's no negative, no positive. And then this one becomes +6, 3. Now, just for argument's sake, we're going to go ahead and draw that. So I've got one point here. That's R. Okay, it stays the same. Then P is 6, 3, which is right there. That's P prime. And 3, 3 is right there. That is Q prime. And S prime is 6, and I forgot the negative again, so -3. So now we can see that we have our drawing. So how do we shrink it? So the best thing to do to figure out how to shrink it is to look at one point. So I'm pretty sure that this point corresponds to this point. So my point for P is 6, 3. And my point for W is 1, 2, 1, 2, 1. So that means I took my xy and I multiplied it by 1/3, both x and y. Okay, so now I go back and I do that, 1/3 x, 1/3 y, and I get 2, 1, and I get 1, 1, I get 0, -1, and I get 2, -1. And now I can see that those are the points that match the new graph. Okay, this becomes P corresponds to point W, Q corresponds to point X, S corresponds to point Z, and Y corresponds to point R. So that's a lot easier than trying to figure out this way, but they did the same thing. I just wanted to show you how to do it. Okay? So on page 472 in your book, they give you this really long explanation of how to prove that figures are similar by mapping them. Okay? So you can look that up in your book. There's a lot of discussion, and look through that carefully. But we're just going to do one or two and show you how that works. Okay? All right, so on page 258, they want you to describe the similarity transformation that maps the preimage, and we always know the preimage doesn't have a prime on it. So this is our starting place. This is our ending place. And they want us to ask you, how are you going to map it? So for me, I think this one, for number 4, I am going to shrink it first. So what I'm going to do is I'm going to look at each of these. I'm going to look at one side, and this is 1, and this is 2. This is 1, 2, 3, 4, 5, 6, and this is 3. So therefore, I can see that my scale factor is 1/2. Okay? So the first thing I'm going to do is I'm going to go ahead and shrink it. So I'm going to take my points, whatever point it is, and I'm going to do a dilation where I go x, y, and I'm starting up at the top, and I'm going to do a dilation of 1/2 x, 1/2 y. Once I've done that, it's going to shrink and look like this. Okay, it's going to look just like this when I shrink it. So now I have to take a point and figure out, and of course you would have to do that work to figure this out. You're going to figure out how to get that corresponding point down to this corresponding point. So I'm going to go 1, 2, 3, 4, 1, 2, 3, 4. So then I'm going to do a transformation, or a translation, sorry. So translation of xy. Remember, you're going to start from this xy, and you're going to go x plus 4, because x is going to the right, and then y minus 4. And that will give me this description. Okay? All right. For this one, think about it. I am going, well, let's do number 6, and I'll leave number 5 for you. Okay? Because number 6 is a little bit harder. So first thing I'm going to do is figure out the scale factor. So look at a corresponding side. So notice that SR is right here, and S prime R is here. So I'm not doing a reflection this time. I am doing a rotation. So now you have to figure out which one are you going to do first. I would shrink it first. I think that would be a lot easier. So the first thing you want to do is say, this side is 3, this side is 1. So this is a shrink by 1/3. Okay? So the first thing I'm going to do is a dilation from my xy, and I'm going to go 1/3 x, 1/3 y. Okay? And then I'm going to do the rotation, and it's counterclockwise. So it's going to be, and a lot of times what you can do to figure that out is first find S. So I'm just giving you some hints on how to do this. So S in my original picture is 3, 6. Okay? So S is 3, 6. And when I shrink it, it's going to be 1, 2. Okay, now the next move has S right here. So I can say, okay, S is going to end up at -2, 1. So now I can compare these, and I'm going to say, okay, here was step 1. My second step is a 90-degree rotation counterclockwise, and that's going to go X, Y, and this helped me make my map. Y goes to the front and is opposite, and X stays the same. So now I have my 2 movements that I'm going to do. So you guys can go ahead and try to finish the description for 6 or do number 5 from the beginning. So just push pause and give yourself a couple of minutes to look at that. When you're done, we'll look at the answers, and then you'll be ready to go. So what they wanted you to do for y is the first thing you were going to do is a reflection, which would take xy to negative xy. So reflection over the, remember we're doing this first, reflection over the y-axis. And then the second thing would be a dilation. And we're going to take this xy, and it becomes our original, and then we're going to go 2x, 2y. Okay, so that's what you should have figured out, and there's the answer for 6. So stop and look at these for a moment and see if you've got the right idea, and then you're done for the day, or for this video.